Right, here we go. Session 11, sequences. This is a really good session to do because it's great revision for GCSE, and also I think you'll find it okay. Right, let's get straight in. Okay, so there's three different types of sequence, or three different types of question we're going to have a look at. First one might even take you back to primary school. We're going to look at some linear sequences. And you might be asked something like this. So we've got a sequence 3, 7, 11, 15, and the question could be find a formula for the nth term. Okay, find a formula for the nth term. Well, it's linear because there's a common difference. The difference is +4 each time. So the nth term is going to be 4n, and then you work out what the previous term would be, which is -1. Okay, so that's the answer to the nth term for a linear sequence. Right, next we're going to look at some quadratic sequences. Again, in the GCSE syllabus, so it's important you know how to do this. And you might get a sequence like this: 3, 6, 13, 24, 39, ... And again, find a formula for the nth term. Okay, that could be the question. Find a formula for the nth term. Now you do the same thing again. So I'm just going to go over the top there. So you work out the difference, 3, difference of the next one is 7, difference of the next one is 11. It's not a common difference this time, but it is if you do the second difference. Second difference common is 4, 4, 4. The differences between them: first differences, second differences. Now they are common, so that means it's a quadratic sequence. And then you can go in and remember, if you remember the formula, so for a quadratic sequence, it's an squared plus bn plus c. That's what the nth term looks like. And you will know, back to GCSE, to work out a, 2a always equals the second difference. So 2a equals 4, therefore a equals 2. I've worked out a. The first difference is 3a plus b. Okay, so 3a plus b will equal 3. I know a is 2, so 6 plus b is 3. B will equal -3. And finally, a plus b plus c equals the first value there. So a plus b plus c equals 3, because that's the first term. So I get 2 minus 3 plus c equals 3. And that -1 plus c is 3. C equals 4. Okay, I don't stop there. My final answer is going to be 2n squared, because that's an squared, plus bn so minus 3n plus 4, because that's what c is. So that's a quadratic sequence. You might need to just pause that and just digest that. You might not have seen that for a little while. Now the third thing we need to do is limiting value of sequence. Limiting value of a sequence. Not all sequences go up consistently or down consistently. Some converge to a value. So e.g. the nth term of a sequence is 2n, this is the question, over 3n plus 2. Part 1, find the first 3 terms. Okay, find the first 3 terms. So when n equals 1, if I put in here, best way to do this on the class whiz is type in exactly as you see it, 2. I'm just going to use x instead of n. That's quite a clever system, this. 3 plus 2. And I can press the calc button there, and I can say when x is 1, press equals, and then equals again, a fifth. So the first term, if I call that nth, I call that, sometimes we call this un. That's the same as the u. So u, the first term, is equal to fifth when n is 2. I just need to press calc again. Don't press clear. Calc again. I'm going to change that to 2 this time. Do it again. 3/8. So u2 is 3/8. And u3, the third term. Again, if I press calc, 3 this time, I get 5/11. And what you'll find is this is converging to a value. Okay, this is converging to a value. So if I go back to the decimal maybe, so 0.4, the first one's 0.2, the next 0.2, the next last one was, what was the last one? 0.45, and 3/8 is 0.375. What's going to happen is this is going to get closer and closer to a value. Okay, it will get, if I did even more, you'll see that it gets closer and closer to a value. And that's what the question 2 is. So find the limiting value. If I went on forever, where would this sequence end up going? That's what the question's asking. Now to do that, I need to say, okay, let n, which is the term number, go really, really close to infinity. Okay, so really, really close to infinity. Now that means any number over n, if n's going really, really close to, really, really massive, this was going to basically become 0. It's going to tend to 0. You can check this here. Any number, it could be 2, divided by, let's just put a really, really massive number in there. Really, really massive. And that is very, very small. It basically, if this was infinity, that would go basically to 0. So any number, doesn't have to be 2, any number over n, when n is going towards infinity, tends to 0. So if we go back to our equation then, un equals 2 to the n plus 1, 3 to the 2. Now the tip here is to divide everything by n. So if I divide every term by n, that's completely fine. I get 2 minus 1 over n over 3, because plus 2 over n. Now, as n goes towards infinity, 1 over n, which is on the top, that is going to go towards 0, and also 2 over n will go towards 0. Okay, so therefore, as n approaches infinity, fx, or not fx, un, the nth term, tends towards 2 minus 0 over 3 plus 0. It's going to go towards 2/3, 0.666. That is my answer. Okay, that's my answer. So the tip there, you divide through by n, and then anything with 1 over n, you basically put it as 0, because as it becomes infinity, we call it tending towards 0. Okay, so a few questions on that now. I want you to do exercise 4H, which is on page 110, and just do questions 3. Oh, sorry. Right. Not page 110. Apologies for that. Okay. Page 111, exercise 4H. Can you just do questions 6, 7, and 8? And then page 113, exercise 4I. Can you just do questions 5, 6, and 7? And then finally, page 114/115, exercise 4J. and you just do the evens. So question 2 to 8. Okay, and that is another session down. One more session to go, and then we've finished chapters 1 to 4, which is really great going. And I'll see you next time.